In my previous video, we looked at how to solve some simple differential equations, first order differential equations, by using the method separation of variables. I didn't quite have time to do my example number 4 at the time, so I thought I'd do that one in a separate video, which is now this one. So the equation that I'm going to solve is x plus 1 squared into 3x plus 1 times dy by dx, and that's going to equal y times this quadratic, 12x squared plus 23x plus 9. And we're also told that the solution curve goes through the point 0, 5. That is when x is 0, y is 5. So we're going to find not just the general solution to this differential equation, but a particular solution as well. Okay, so let's just first of all make dy by dx the subject, so we can see what's going on here. We've got y times 12x squared plus 23x plus 9, and that's all divided by what was timesing by the dy by dx, which is x plus 1 squared times 3x plus 1. Okay, and now we can separate the variables, although you don't have to write this step. You can go straight from that to separating the variables if you're able to do so. We end up with 1 over y dy equals 12x squared plus 23x plus 9, all divided by x plus 1 squared times 3x plus 1 dx. Now that, again, as I said in my previous video, does not make any mathematical sense as it stands, but as soon as I pop an integration symbol in there and an integration symbol in there, it makes sense. And we can do it. So the left-hand side is going to become the natural log of the modulus of y. Okay, nice and straightforward. And the right-hand side is less straightforward. We're going to need to use our partial fraction theory to separate this into integratable fractions. So we're going to use partial fractions here. So let's separate it out. This is going to be something divided by x plus 1 plus something else divided by x plus 1 squared plus something else divided by 3x plus 1. Okay. So that's what this integrand, the contents of the integral, the integrand is identical to this for some a, b, and c, which I need to work out. So if I take this identity, okay, that's this fraction is identical to these 3 fractions summed together, then multiply the whole thing by the denominator of the left-hand side, I'll end up with 12x squared plus 23x plus 9 is identical to a into x plus 1 times 3x plus 1 plus b into 3x plus 1 plus c into x plus 1 squared. Okay. Now from here we need to find our values of a, b and c. You can either sub in some different values for x to this identity to find a, b and c, or we can equate the coefficients. If you've seen any of my previous videos, you know I prefer to equate the coefficients. So equating the coefficients of x squared, on the left hand side we've got a 12. Okay, 12x squared. On the right-hand side, we're going to get 3a. Nothing there, there's no quadratic term there, plus c. The coefficients of x to the 1, that's the linear terms. We've got a 23 on the left. We're going to get 1 plus 3 is 4, so I get 4a. Plus 3b. And over here, when we expand that, we're going to get a 2x. So we've got 2c from there. And then the x to the 0 term, which is the constant, we've got 9 on the left. That must equal a times 1 times 1, which is a, plus b times 1, which is b, plus c times 1 squared, which is c. So there we go, we've got a, b, and c. 3 equations. Now, the exam would know full well that you are allowed a calculator in the exam which can solve these. So whether it's this one or the FX991, you can use it because it's a linear system. So linear simultaneous equations, it's simultaneous, so we can push F1. It's got 3 unknowns, and the first equation is 3a plus no b plus a c is 12. The second equation says 4a plus 3b plus 2c is 23. And the final equation says a plus b plus c is, oops, that should be 1. A plus b plus c is 9. That's not the answer I was expecting, because I didn't push in the 9. There we go. So we end up with the solutions. A is 2, B is 1, and C is 6. So A is 2, B is 1, and C is 6. There we go. Okay, so that allows us to rewrite this integral as the sum of 3 integrals. Let's turn the page and get that written up. We know the left-hand side was already the natural log of mod of y. And the right-hand side is now going to be these 3 integrals, which was 2 divided by x plus 1 dx, plus the integral of 1 divided by x plus 1 squared dx, plus the integral of 6 divided by 3x plus 1 dx. Okay, so now we can tackle this because we can do each of those integrals separately. And we're going to take advantage of the top being the differential of the bottom for these 2 cases, and we're going to take advantage of the other rule, the other special case, for this one. Check out my previous video for that. So log of modulus of y, I'm going to say, is 2 times the integral of 1 over x plus 1 dx, plus the integral of 1 times x plus 1 to the minus 2 dx, plus 2 times the integral of 3 over 3x plus 1 dx. And I've done that so we can see the top is the differential of the bottom here, the top is the differential of the bottom here, and the 1 is the differential of the contents of that bracket there. So we can apply our quick rules. So that's going to be 2 times the natural log of the mod of the bottom, minus x plus 1 to the minus 1. Okay, so we can add 1 to the power divided by new power here. Plus 2 times the natural log of the mod of the bottom. And now we can add our constant, which you can add a plus c. I'm actually going to add a log k because I'm going to combine it with the logs. Okay, particularly as I've got a log here as well on the left. So lots of logs will just combine into one, and then I can get rid of them. And I end up with just an e, which will affect that term there. So combining the logs, we're going to get log of mod y is going to be equal to the natural log of the mod of k times x plus 1 squared times 3x plus 1 squared. And then I've got this extra term here. And then I can raise both sides to the power of e. So that will give me y on the left. That will give me the contents of the log there, which is k times x plus 1 squared times 3x plus 1 squared times e to the minus x plus 1 to the minus 1. Okay, so that's my general solution. This is the solution to the differential equation, but it's got the arbitrary constant in it. Okay, so for every value of k, we'll give a solution, and every solution will give a value of k. So let's have a look at some of these curves. Let's see what our k does as we change it. So here we have a particular solution, but as I vary my value of k, then we can see how the curve changes. We can see it's stretching up, and then it's coming down again. There we go. And if you notice, a bit of a flash, but very quickly, we're close when k was 0, we saw a little, that was gone. I'm sure we saw a little flick of a parabola kicking around. There it is. There it is. It's coming up now. There we go. It's not a parabola, but we get a little bit of a curve to the left as well. It doesn't just stop at -1. It does exist. It just gets very big very quickly, and that's because of the exponential term. So we can see this, what the varying the coefficient k does. Stretches the curve, and that gives the general solution to the curve. Now to find the particular solution, we're going to use the fact that it goes through the point 0, 5. That is when x is 0, y is 5. So if I use that, x is 0, y is 5, I can say that 5 is going to equal k times 1 squared times 1 squared times e to the minus 1, which is k over e. And that tells me that k, my arbitrary constant, must be equal to 5e. Now, that's the value of the arbitrary constant for my particular solution. So that gives me then the particular solution, y equals 5e to the x plus 1 all squared, 3x plus 1 all squared, e to the minus x plus 1 to the minus 1. And we can do a little bit more tidying up. I'm just going to combine the e's together to give 5 into x plus 1 squared, 3x plus 1 squared, e to the 1 minus x plus 1 to the minus 1. I can tidy that up as well. This exponential is e to the 1 minus 1 over x plus 1, which is e to the x plus 1 over x plus 1 minus 1 over x plus 1, which is e to the x over x plus 1. So I can write it then as my particular solution is y equals 5 into x plus 1 squared times 3x plus 1 squared times e to the x into x plus 1 to the minus 1. And I'm going to leave it like that.